the rhombus has all the properties of the parallelogram. Okay, we've got opposite sides are parallel. Opposite sides are congruent. The opposite angles are also congruent. Here we have this angle measures the same as this one. We have, in this case, we have two acute angles that have the same measure, and then we have over here, these are opposite, so these are obtuse angles. We have the consecutive angles measuring 180 degrees. So if we have A, B, C, and D, let's take C. C plus B would equal 180. C plus D would be 180. D plus A is equal to 180, and so forth. We also know that the diagonal cuts this into equal triangles. So if I did one like this, here would be my two triangles. And if I did a line this way, that would be two equal triangles here, these large ones. So those are all the properties of the parallelogram. So what makes this a rhombus? All the sides are congruent. Oh, I have to go back. So the opposites are not only congruent to each other, they're all congruent. So let's add another one of these to each one. So this is the same length as that, same length as this, same length as this. A rhombus is kind of like a square that was pinched and it popped into this rhombus. Baseball diamond, maybe you could think of it like that, with home plate, first, second, and third. It's the same to run from home to first base as it is to run from first to second, second to third, and third home. Because in a rhombus, the sides are all congruent. The angles, the diagonals, are perpendicular to each other. So when we did this, we knew that this portion of the line was the same as this one, and this portion of the line was the same as that diagonal. But where they cross each other, those form right angles. So here in the middle are the right angles. (90, 90, 90, and 90). That would make sense because the total number of degrees in the interior angles is 360. It is a quadrilateral. That's made up of the acute and obtuse angles at the A, B, C's, and D's, but these angles that form with the diagonals are also adding up to 360 because they're all perpendicular. That means they meet at right angles. These diagonals bisect the angles. So the diagonal itself cuts A and C in both sides of it into equal portions and D and B into equal portions. So let's say our obtuse angle is 100 degrees. That would make these two be 50. And if this one measures 100 degrees, then it's 50 on both sides after the bisector goes through. If A and C are 80 degrees, that would make the bisectors cut it in the angle, the two smaller angles be 40 apiece. And I think the math works out on that. 180, 280, and 360. And all of these are 90, that's 360 in the middle. So the thing that makes the rhombus different than just a plain old parallelogram, which it is a parallelogram, but it has four sides that are the same measure, and the diagonals make this perpendicular. They make perpendicular angles inside of it, and the bisectors, the angle bisectors, cut the angles into equal portions to rhombus.